Hey guys, I'm going to go over a few more problems on solving using substitution. Again, we look for the variable that's all by itself. We see that x is by itself. It's equivalent to y minus 1. So that means in this equation, I can come down here and take out this x and in its place put what x is the same as. So I have negative plus y equals negative 1. I'm going to substitute in this value of y minus 1 in place of my x. And now I can see that I need to distribute this 1. So this negative 1 out here. Negative 1 times y is negative 1y. Negative 1 times negative 1 makes it a positive 1 plus y equals negative 1. Commutative property allows me to change the order so that I can put my y's side by side. Negative 1y plus 1y is 0, so I'm left with 1 equals negative 1. This is not a true statement. So we know that this problem has no solution. If we end up with something that's not a true statement, it is no solution or it's inconsistent. So since this is inconsistent, what does that tell me about the graphs? If you think about it, we know that if we were to write these both in slope-intercept form, we would have y equals x plus 1, right? I just moved the 1 over. And on this one, if I move the x over, I would have y equals x minus 1. So they have the same slope. There's an understood 1 in front of here, but different y-intercepts. So that tells me if I was to graph these lines, one's down here at negative 1, one's at positive 1, goes up 1 over 1, up 1 over 1. So here's this one. This one starts at positive 1 and goes up 1 over 1, up 1 over 1. So we look at the graph of it, and while my lines are pathetic, they're not very straight, we can see that these are parallel lines. They're never ever going to intersect. They're not going to touch, so we know that there is no solution. This is an inconsistent system. And I'd like to do one more word problem. Says tickets were sold for the game. Student tickets cost $3. Adult tickets cost $5. Mr. Johnson wants to present a proposal to the school board suggesting they lower the price of student tickets and raise the cost of adult tickets so more students can come and cheer on their peers. Says when making his presentation, he realizes he doesn't know how many students or adults came, but he knows that 327 tickets were sold and that $1,381 was collected. Can you help him figure out how many student tickets and how many adult tickets were sold? So let's think about this. Adults cost $5, so we'll let adult ticket be, let's just say A, and they cost $3 or $5 each. Okay, student ticket, we'll say S, and they are $3 each. So they've sold a certain number of adult tickets, a certain number of student tickets, and we know that they sold a total of 327 tickets. So thinking about the A representing the number of adults, the S represents the number of students, and there were 327 total tickets sold. Okay, we also know that each adult ticket was $5. Each student ticket is $3. And they raised a total of $1,381. So we have just came up with our system. Now we need to solve it. So I'm just going to subtract S from both sides. So I have a negative S plus 327. Now I can take this value and substitute it in place of my A. Since A is the same as this, I'm going to come over here and I'm going to take the A out and put what it's the same as. So negative S plus 327 plus 3s equals 1381. If I work out a problem and I end up having two variables in it, then I know that I've made a mistake somewhere, because the whole point of substitution is to make sure that I have it all written in terms of one variable. So 327 times 5 is 1,635. Plus 3s equals 1381. I'm going to combine my like terms. So I have negative 2s equals 1381 minus the 1635. And I get negative 254. Divide both sides by -2, and I end up with 127 student tickets were sold. So if we sold 127 student tickets, we can come back up here and quickly realize that there must have been 200 adult tickets sold, because 200 plus 127 equals 327. So, and you can plug it back into this one and check too. 5 times 200 is 1,000. 3 times 127 is 381. 1,000 plus 381 is $1,381. Hope that made sense. Hope you're enjoying these lessons on substitution. If you have any questions, be sure to let me know. Have a great day, guys.